Right? This way. Guys, those who are online, are you able to see the board clearly?
Yes, sir.
Sir, you're on mute, sir.
Sir, you're not audible. Sir, sir, sir.
the laptop. Right. So again, the function is for you to check the differentiability of a given function. The first condition that should get satisfied is it should be continuous at the point where you're trying to check the differentiability. Okay, I'll just put it as it should be continuous at the point. Okay, this is the first condition that should get satisfied. Secondly, if you observe, let's say you have x-axis and y-axis, and you have a function like this. Okay. Now the question is about checking the differentiability of a function at a given point C. Okay. Let's say something like this. Then let's say, where is the voice? Did anyone switch it on? Laptop. So, show what the sound is. So if you're trying to check the differentiability at points, listen to this. If I take a point on the right of this at a distance h, then this point is going to be c plus h comma 0. Correct? If I take the same point on the left of it, then this is going to be c minus h comma 0. Okay. So it should be c minus h comma 0. So if I take this point, then it's c plus h comma f of c plus h, correct? Guys, those who are online, can you respond? Hamsini, can you tell me if I'm audible?
Yes, sir, you're audible.
So c plus h comma f of c plus h, correct? Then what about this point?
C plus H
So
comma
the function y is equal to f of x. This is c minus h comma
F of C minus.
That's it, right? Now let's think of this thing. So this point will be c comma f of c. So if I take these 3 points as ABC, right, I am trying to draw a slightly zoomed version of AB. I will call this as AB. Then this point is c comma f of c. And this point is c minus h comma f of c minus h. Right. So through these 2 points, can I draw a line? Now, what is going to be the slope of this line AB? What is slope of a line? Y2 minus Y1. So f of c minus f of c minus h divided by c minus h. Correct? Okay. So when this is the scenario, observe. Then I can write this as f of c minus f of c minus h divided by h. Any doubt in this? Clear, right? Now what I will do is, this is slope of the line AB, but this line AB with respect to the curve, what is it? This line AB with respect to the curve, what is it? It is secant. Now the question is, when can the secant turn into a tangent? It touches a point. So here, which parameter has a tendency to tend to 0? H. So if I apply limit h tends to 0, f of c minus f of c minus h divided by h. Then this is what is the mathematical definition of dy by dx. So if you see the basic definition of differentiation or derivative is limit of something that is h tending to 0. F of the value minus f of c minus h divided by h. Okay. I have just add one point. This is called as dy by dx. If you put a line, you read it as at. So dy by dx at x is equal to c. F of c minus c minus. So look at f of c minus f of c minus h. The clear guys, please make a note of this. This derivative is also called as left hand derivative. So BC will be right now. We have to find this. Here. No. Here of this. Now what about the right hand derivative? If I take BC, right? If I take this point as B, this point as C, then this is going to be the secant, right? So what is this point? C plus H comma F of C plus H. What about this point? C comma F of C, right? Now, what is going to be the slope of BC? That is F of C plus H minus F of C, the whole divided by C plus H minus C. Cancel it. So it is going to be F of C plus H minus F of C, the whole divided by H. Correct? Now what will happen if I apply limit to it? Limit h tends to 0. F of C plus H minus F of C, the whole divided by H. Then this is also called as dy by dx at x is equal to c. And the more technical name is, call this as right hand derivative. with this? The question is, when can you say the given function is differentiable at a point? So when the left hand derivative is equal to the right hand derivative and it should be equal to the derivative. So left hand derivative should be equal to right hand derivative should be equal to f dash of c. So you know the different ways of writing derivative. One is dy by dx is the same as f dash of x is the same as derivative of f of x with respect to x, right? It's the same as y with a dot on top of it. It's the same as y1. It's the same as y dash. All these are different ways of writing the same derivative. So when you write something like this, it's called as the first derivative. So yeah, these are all the symbols that are used for first derivative. And in your mathematics, the symbols that are used are either by dx, f dash of x, y1 and y dash. These are the symbols they use. This is not used often. Okay. So similarly, if you write something like b square y by bx square, it's called second derivative, or f double dash of x is the same as y with two dots on top of it is the same as y2 is the same as y double dash. Okay, going forward, we'll be using these kind of symbols also to get used to. Similarly, if it goes to 3 dash, 3 dots, 3 dash. So it keeps on going. Okay. So now I hope this makes sense, right? Left hand derivative is equal to right hand derivative is equal to the derivative of the function at that point. So it is then you can say that the function is differentiable at that so-called point. Even before all those things, even before you check the derivatives, what are you supposed to do? First check the continuity of that function. If the function is not continuous, then itself you can do it. You need not sit and waste your time on finding the derivative. Okay. So shall we start? Yes. Will you give me a problem? The next. Sign off. It's time. I think they have asked to differentiate it, right? It's not about differentiation. Where is it?
166.
So ninth one, let's see. So what are the question? Exercise 5.2. Ninth question. What is it? Given function f of x is equal to
Modulus x minus 1.
what?
It's equal to 1.
So we need to find whether it is differentiable or not. Or they're asking us to do something.
Not
Let's assume that they're asking us to find whether it is differentiable. So what will be the first thing you do? First is define the function. Wherever modulus is there, define the function. Look at the way I'm going to define. I will write it as x minus 1 when x minus 1 is greater than 0. Are you guys comfortable if I directly write it as x is greater than 1? You guys know the reason why it is so, because whenever you are defining modulus of x, right, then you should write it as x 0 minus x, where capital X is greater than 0, capital X is equal to 0, capital X is less than 0. In the case, if you relate it to this question, what is capital X? X minus 1. So x minus 1 is greater than 0 means x is greater than 1. 0 when
x equal to 1.
minus of x minus 1 when x is less than 1. By default, you can say that this function is continuous. Without a doubt. Right? It is continuous. If you want, you can check the left limit right. So left limit, what is it going to be? You substitute this thing. For left limit, you substitute this. What is the answer? Substitute 1 here. You will get 1. You will get 0. It's a continuous function. But for you to check the differentiability, what are you supposed to do? Take the left-hand derivative. What is the formula? See, only difference is if at all you are going to read something from textbook, right? They have given something like this. How I took this? I took c minus h here. I took c here and c plus h here. Right? Now, for left derivative, I came for right to left. See, I took it as f of c minus f of c minus h divided by h. Limit h to 0, this is what I would have taken. But in your textbook, what they would have done is they would have done f of c minus h minus f of c divided by minus h. Both are the same. Okay. I don't remember where it is, but I've seen it in the textbook. If at all you read it, don't get confused. Both are same. So what logic I generally use? I go from right to left. So from middle, if I go to left, I'm finding left hand derivative. From right, if I go to middle, I'm finding the right hand derivative. That is how I remember. Are you able to understand the logic? Yes. So that is why you see the formula will be like that. So now tell me, limit distance to 0 is common in both. Where should I start from? Middle to left. F of c minus f of c minus h divided by h. Correct? Right. But here what is c? Limit distance to 0. F of, in the place of c, what should I write? C is 1. So f of 1 minus f of 1 minus h. Again, the left hand value divided by h is h only. Okay. Now this is limit distance to 0. Now look at the function. What is f of 1? F of 1 is 0. Minus f of 1 minus h. 1 minus h now lesser than 1. What should I take? I should take this function. So minus of 1 minus h minus 1. Did you understand what I mean? Minus is from here. Okay. In the place of x, I wrote it as 1 minus h and minus 1 is there. Divided by h. So 1 and 1 are gone. So what will you get? Minus of minus of minus. Minus h by h. So you get limit distance to 0 minus h by h. Cancel it. You are going to get minus 1. Actually, the step will be like this. Limit distance to 0 minus 1 is minus 1. Clear? Using the same logic, I give you a minute time. Find out the right hand derivative. What is f dash of 1? Left hand derivative is minus 1. Right hand derivative is 1. You get 1. What is the exact derivative at this point? Why is it 0? Because f of x is 0. F dash of x will also be 0. You are going to differentiate this function. You understood why you differentiated only 0, not exponential, not exponential? Because that is the equal to that. I wanted to explain now, right? Why don't you have got it? Left hand derivative, right hand derivative are not matching, but I want to explain what is the meaning of it. Not multiple times. You draw only one tangent because it's a straight line. You can draw tangents only to a curve. How can you draw tangent? Right? So right hand derivative, is there anyone having doubt? Those who are all in any doubt? So right hand derivative, yes, you would have got 1. Right? So I want to explain what is the significance of it. So did you understand? Though the function is continuous, it is not necessary to be differential. Because if I look at it graphically, right, this is x-axis, y-axis, x dash, y dash, where will the graph get shifted? Will it go above or below? You have x minus 1, so it should go below, right? But it will not go. It will go here. Why? Because at x is equal to 1, it is sorry, I mean it's neither below nor above. It is above whether it gets shifted to the right or left. It gets shifted to the right. Why? Because it becomes 0 at x is equal to 1. So x is equal to 1 is somewhere over here. Okay. So this V graph will get shifted to the right by 1 unit and you will get a graph like this. Accepted? So what happened on the left of 1? When you found the derivative, what is the answer you got? You would have got minus 1. You know what is the meaning of that minus 1? If you take this angle, how much is this angle? 135 degrees, correct? What is tan 135? So according to the concept of straight line, tan of angle made by the line with the x-axis is called as slope. And according to differentiation, dy by dx is also slope. Right, slope of the tangent. So that will be minus 1. What happened on the right of it? This is 45 degrees. What is tan 45? Well, that is why you got right hand derivative. Okay. So had it been a competitive exam, you could have done it even shorter. I'll tell you how. Use this logic. See, I'm repeating it. I'm scared to tell this, but use this logic only to check whether it is differentiable or not. With respect to secrecy, you have to write all those points. And whereas if the same question is asked in competitive exam, f of x is equal to what did you get? X minus 1, 0 and minus of x minus 1. X greater than 1, x equal to 1, x less than 1. Correct? Now what you can do is directly find out f dash of x. If you find out f dash of x, this is 1, this is 0, this is minus 1. For x greater than 1, x is equal to 1. The right derivative, left derivative, exact derivative. Means you can directly differentiate. So for example, the question is like this: f of x is equal to x square plus 1, x square minus 1, x greater than 1, x less than 1. For example, there is a question like this. If they ask you to check whether it is differentiable or not, first thing I don't think it is continuous. So how much are you getting? X square, you are getting 2, and this is
0.
so read the question. For example, let's say it is 3 minus x square. Now it works. Now are they continuous? Because we don't have x equal to 1. I'm not talking to differentiability, I'm talking to continuity. Are they continuous or not? When you substitute 1, 2, 2, and 2, it is a continuous function. So if they ask you to check the differentiability, do this as a number. And then you go with the LHD and RHD process. So when you do 2x 0 minus 2x, this x greater than 1, x equal to 1, x less than 1. Now substitute the value 1 there. So what will you get? 2, 0 minus 2. So this is the right hand derivative, 0 left hand derivative. This is a continuous function but not a differentiable function. If you want, you can check with the left hand derivative and right hand derivative. These are the exact values you get. Are you to understand the concept? Is it clear? Now you understood the meaning of differentiability means when you say given function is differentiable at that point, you can draw only one tangent at that point. That's the meaning of it. If you draw more than one tangent to the same curve at the same point, then it is not said to be differentiable. So if you want to know what is the meaning of differentiability, write it down. Meaning of differentiability. Drawing only one tangent. Drawing only one tangent to a given curve. Drawing only one tangent to a given curve at the given point. At the given point makes the function what? Differentiable. Else it is not differentiable function. Okay. here, having said this, try the next problem. 10th one, what are they asking? F of x is equal to mod x. Prove that this is a function which is not differentiable at x is equal to 1 and x is equal to 2.
So it's greatest integer.
What is mod? Sorry, greatest integer. So at integral point, it is not continuous. Hence, it is not. So since the points they ask are integer points, at integral points, the function greatest integer is not continuous. Hence, it is not. That's it. Okay. So that is all about differentiability. Now you need to know how to differentiate composite functions. Right? So yesterday I told you, right? You have something called as composite functions. So derivatives, right, or the heading as derivatives of composite function. Derivatives of composite. You know what is a composite function? F of g of x. I'm not talking about the domain and codomain and all those things. There is nothing to be mentioned in this last differentiate. Okay. So if you have f of g of x as the function y, then dy by dx is like this. It is f dash of g of x into d by dx of g of x. And this is something similar to a product group, but it is not called product group, rather it is called chain group. If at all you want to use this basket in physics, you have to put simple mathematics. Right? So this process is called chain group. Okay? That's all. Nothing else. You can directly start solving the problems. This 5 minutes will be complete. Let me start. What is the first question? Find the derivative of sine of x square, correct? X square plus 5r. That is from the exercise. It's the same logic. Simple. Another. So dy by dx is equal to, look at the function. It is a composition of these two functions, sine and x square plus 5. So that x square plus 5 is what is g. Okay. So how I generally do this, I will not look at what is inside. First, I'll start with sine. So derivative of sine is cos. So write cos. Cos of what? Right? The same thing inside. X square plus 5. Okay. Then put a dot. Into. Now get into the argument. That is d by dx of x square plus 5. So how much is the answer? Cos of x square plus 5 into rearrange the bracket, that will be the answer. 2x cos x square. Okay. Second, what are the cos of sin x? So y is equal to cos of sin x. Simple again. What is dy by dx? Tell me. Cos is minus sin of whatever is inside, write it as it is, into d by dx of sin x. That is going to be cos x. Correct? So minus sin of sin x into cos x. Okay. The next one. Next one. Third one.
Sine of x plus 8.
That's it. Okay. Then can you write it as y dash? dash. You're comfortable with this one. Y dash is equal to cos of ax plus b into d by dx of ax plus b. So it is going to be cos of ax plus b into b. Okay. So to put it in simple terms, whatever are the number of functions that are combined is equal to the number of steps we need to make. Understood? Sine one function, ax plus b another function. One step, two steps. If there are three functions inside, three steps. Okay. Finally, whatever we want to manipulate and write, that's a different story.
So the d by d exists necessary.
Better you write, you get practice. See, these are all simple problems. What is it? Three functions combined. What is the practice? I think you will have such kind of problem. Y is equal to sine of
Secant of tan of root x.
secant tan root x. So there are three functions, right? So you should get the answer in three steps. So y dash is equal to derivative of secant into tan of tan root x. Correct? Into what's the rate? D by dx of tan root x. So first step is done. Second step, don't disturb it. So secant of tan root x into tan of tan root x into derivative of tan secant square root x into 1 by 2 d by dx of root x. So again, secant of tan root x. So I can combine these two for my secant of tan root x into tan of tan root x into secant square root x into 1 by 2. One more three more, you can answer directly after you practice. First thing is an application. Maximum will cover 1 month. Okay. What are the questions?
Sine of ax
By
cos of c.
See, this will be the last problem I do for this exercise. Remaining, I have already solved. We'll go to the next one. Inverse will come to the next one. So we'll start there. Okay. So what is y dash? U by v. So if you see how many combinations? 1, 2, 1. So actually you have 4. Let's see. So u by v, what is it?
Cos c.
V into derivative of this. Derivative of this is how much? Can I directly write now? Okay, cos of a is correct. Minus
Sine of x
sine of ax plus b into
minus sine
very good minus sine of cx plus b into the whole divided by
cos of x.
cos of cx plus b. We take the a outside and simplify. So you cannot simplify it. Actually, had a big c taken out and take sine cos a cos b minus sine x. Okay. So make these minus signs and combine them to this one. Is that clear? This is a simple exercise. So let me get started with inverse trigonometry. Right. And I love this. So derivatives of inverse trigonometry. First one, if I have y is equal to sine inverse x, what is dy by dx? How do they get this? Why do you substitute cos instead? Sin inverse is there. Why do you use cos this? Wherever inverse is there, right? Will you check this one? What will you do? You substitute sin theta. So substitute x is equal to sin theta, and in the first step itself do something like this. Theta is equal to sin inverse. That is in your mind. Okay. So when you substitute it, then you get y is equal to how much? Theta. Place. I will take sine on both sides. Can I do that? If I take sine on both sides, I get sine y is equal to xr. Differentiate on both the sides.
What's the d by dt?
Differentiate on both sides. You should always write this with respect to what? With respect to x. So derivative of sine cos y into what is y and writing dy by dx? Because change is equal to derivative of x is 1. From this, what is dy by dx? 1 by cos y. But what is cos y? Can I see it? Can you write it as root of 1 minus sin square by? But what is sin y? Sin y is x. That is why you got 1 by root of 1 minus x. Okay. Clear? What about cos inverse x? So y is equal to cos inverse x. Then dy by dx will be negative of this 1 minus 1 by root of. How can you get this? Can you try? For the sake of practice, take cos on both the sides. Do it fast. So take cos on both the sides. Cos y will be equal to x. What will you do? Then try for tan inverse. So you would have got cos y is equal to x. Next step, minus sin y into dy by dx is equal to 1. Minus and root of the theta. We will get dy by dx is equal to minus 1 by sin y minus 1 divided by root of 1 minus x square. Correct? Listen. Sin inverse x plus cos inverse x is equal to pi by 2. Correct? Now differentiate on both the sides. What is the derivative of sin inverse x? 1 by root of 1 minus x square. Plus, this is dy by dx because that is only y is equal to 0. So dy by dx is equal to take it to the other side. Minus 1 by root of 1 minus x square. That is the reason why the complementary functions, the inverse of the complementary trigonometric functions will have the derivatives with positive and negative signs. Similarly, when you do for tan inverse x, you will get one value. That value will be negative or something. What is it? For cot inverse x. And a tan inverse x plus cot inverse x and pi by 2. Similarly, secant inverse x and cosecant inverse x derivative will be opposite sides of each other. But values will be same. So that's the logic. Okay, shall we go with tan inverse? So you want to do the derivation, don't memorize the formula. So y is equal to tan inverse x. So tan y is equal to x, which implies secant square y into dy by dx is equal to 1. For dy by dx, 1 by secant square y. How can you write secant square y in terms of tan y? 1 plus tan square y. And this will be 1 by 1 plus x square. So part inverse x and minus 1 by 1 plus x square. You need not sit and do whole thing. You can use this logic. Okay. Similarly, can I go for the fifth one? So y is equal to part inverse x. dy by dx will be minus 1 by 1 plus x. Fifth one is secant inverse by dx. So y is equal to secant inverse x, which implies del x. Secant y is equal to XR. So secant y derivative is secant y into tan y into dy by dx is equal to what? Correct. Dy by dx is what? 1 by secant y into tan y. See, secant y is x itself. Okay. So can I write this as 1 divided by secant y into root of secant square y minus 1? Can I write it? So this will be 1 divided by x into root of x square minus 1. That's the answer. Now what is cosecant inverse of x square? Minus 1 by x is the root of x square minus 1. See, one point where you might get confused with sin inverse x and secant inverse. For sin inverse, the denominator is root of 1 minus x square, whereas for secant inverse is root of x square minus 1. X square minus 1. I'm talking about the square root rather than many people get confused. I've seen mistakes. Okay, they write it as x into root of 1 minus x square. X into root of x square minus 1. Okay. Don't make the mistake. Shall we try out some problems? What else? Enter. It's a mistake. What is it called? I will do some problems. 5.3, right? First question then. Y is equal to 2x plus 3 is equal to sin x. So implicit functions are there, no? Okay. I will tell you about implicit functions. Derivatives, please write down this screen. It's very simple. Derivatives of implicit functions. Okay, so I need to explain you about what are implicit and explicit functions. Any idea? So generally, if you are able to split and write the function as independent and dependent variables, we call it as explicit. Because you are explicitly able to write them as two different values of equal to sign. Right? So if you are able to write any function as y is equal to f of x, in the sense, left hand side is dependent variable, not variables. Left hand side is dependent variable. Right hand side is an expression of independent variable. In the sense, y is equal to x square plus 1. Is it an explicit or implicit function? It's an explicit function. So y is equal to x square plus 2x plus 3. Explicit. So y is equal to x sin y plus 2. Because for this kind of a scenario, it's difficult for you to split y and right. Right? So it will be a combination. So when these kind of functions are there, you directly start differentiating on both the sides. That's it. There is no step procedure or something. Directly start differentiating on both the sides. So that is why what is the first question? Y is equal to 2x plus 3y equals to sin x. 2x plus 3y is equal to sin x. See, this still I can write it as an explicit function. Can I? It is actually not an implicit function indicator.
Sin x.
You can still split and write it. Y is equal to sin x minus 2x divided by 3. Okay, but what we'll do is, for the sake of doing it, start differentiating on both the sides. 2 plus 3y dash is equal to cos x. Now y dash is how much? Cos x minus 2 divided by, right? See, logically, if I rewrite this function as y is equal to sin x minus 2x divided by 3, then y dash would have been cos x minus 2 divided by 3. Correct? They both are same. So what I do, I converted this implicit into an explicit function. Yeah, 3 is constant. You use u by v only if the denominator is a function. With a constant function, you will not use. Constant of 1 by 3 into d by dx of the actual meaning is this. With the meaning, both the same. Here, let proceed. Next one.
2x plus 3 equal to sin
2x plus
3 equal to sin
sin beta. So 2 plus 3y dash is equal to cos y into y dash. Right? So 2 divided by 3 minus cos y. Sorry. Cos y minus 3 will be y dash. Correct? So this will go to the other side. Y dash into cos y minus 3. So bring the cos y minus 3. Next. Implicit you guys can do it. We go for inverse. What is the problem? Sin
inverse of 2x by 1 plus x square.
sin inverse of 2x divided by 1 plus x square. So what will you do?
Sin theta by 1 plus x.
It's a direct formula. This is the problem. Y dash is 2 by 1 plus x square. One common mistake is they'll start differentiating directly. Sin inverse derivative, they'll write 1 by root of 1 minus 2x by 1 plus x square the whole square. So most of the inverse trigonometric list problems, instead of using direct formula, you will have to either do a substitution or simplify it and then solve. You have to understand. So you can ask me, suppose you didn't get this idea, what will you do? And then I will see x is equal to, I'll substitute tan theta. If I substitute tan theta here, what am I going to get? Sin inverse of sin 2 theta is equal to y. Correct? Then 2 theta will be equal to y. Correct? So listen, I will find dx by d theta. How much is it? Dx by d theta is what? Secant per theta. You understood why I found the dx by d theta? Slightly far. X is the independent variable. Sorry, x is the dependent variable. Right hand side is dependent on theta. So dx by d theta is secant per theta. You have to understand. I call this as equation number 1. Here, what will I do? 2 into d theta by dy is equal to what is the equal there? See, this is also a part of this. It's called parametric differentiation. I'll teach at that point. That is what I actually did. But forget it. You got 2 theta, right? Then you can write this as 2 tan inverse x equal to y. That's skipping this. That's what I did. Let's start differentiating. Next one. 10th one.
Tan inverse of 3x minus x. 1 minus x.
Tell me, what is this?
Tan theta.
Tan 3 theta. 3 tan inverses. Right. You put x is equal to tan theta. tan inverse of tan 3 theta. We need to substitute into 3 tan theta minus alpha. This will be 3 theta. 3 into what is theta is? So it is 3 tan inverse x. Don't write it as tan inverse x. So it is 3 tan inverse x. Then y dash is equal to all of this. That is all you need. Clear? So you guys try the next one. So y is equal to cos inverse of 1 minus x square by 1 plus x square. That is also a direct formula. What is it? 2 tan inverse x. Video order substitute tan. It's a direct formula. The sixth property, you remember? You won't get idea, substitute tan theta. So you get cos inverse of cos 2 theta. So what is the answer for third one? I mean 11th one. 2 tan inverse x is the function. What is the derivative? 2 by 1 plus x square. Finish. So 2 divided by 1 plus x square. Next one is pretty easy. So you can solve it. Is there anyone wants me to solve 11th and so? Anybody wants me to solve? 11. Cos inverse of 1 minus x square by 1 plus x square. What is it? So 12th and y is equal to cos inverse of 2x by 1 plus x square. Correct? Okay, what is it? Sin inverse of? So 1 minus x square by 1 plus x square is generally what? Cos 2 theta. So what you can do is you can put x is equal to tan theta, then y will be equal to sin inverse of cos 2 theta, right? But we can eliminate sin inverse only when we have sin inside. So I write it as sin inverse of sin of pi by 2 minus 2 theta, right? So when I do this, I get pi by 2 minus 2 theta, but what is theta? So y will be this value. So y dash will be how much? 0 minus 2 divided by 1 plus x square. So minus 2 divided by 1 plus x square is the answer. Is that clear? So using the same logic, solve the next one. It's exactly the reverse of this. Derivative of pi by constant 0. Thirteen, what is the answer? Same. Minus 2 by 1 plus same logic. So y is equal to cos inverse of 2x by 1 plus x square. So this can be written as, so you put x is equal to tan theta, substitute here, y will be cos inverse of sin 2 theta, this is cos inverse of cos of pi by 2 minus 2 theta, then this is y, then y dash is minus 2 by 1 plus x square. What about the 14? Y is equal to sin inverse of 2x into root of 1 minus x square, correct? So what will you substitute x as? 1 minus x square means we put x is equal to sin theta. So y will be equal to sin inverse of 2 sin theta into cos theta. This will be sin inverse of sin 2 theta. This is y. So y dash will be 2 2 theta. But what is theta?
2 sine inverse x.
Y dash of
2 by root of 1 minus x.
clear? 2 by root of 1 minus x square. So how will you do the next one? Last problem, right? Do you have anything in that? So y is equal to secant inverse of 1 by 2x square minus 1, correct? So what will you put x as? Cos theta. Then y will be equal to secant inverse of 1 by cos square theta minus 1. So what is this? 1 by cos theta. So secant inverse of 1 by cos 2 theta. So the secant inverse of secant 2 theta is 2 theta. But what is theta?
2 cos inverse x.
So 2 cos inverse. So y dash and
Minus 2 by root of 1 minus x.
clear. So what is the next exercise? Exponential logarithm. So now which exercise there? See, math which we can have next Tuesday. Next Tuesday, we have math because then state would be mistakes. Physics. We will try to both on state. We will have to take the challenge.
So what not to say about this?
Other better. So if we go with math this on Tuesday and Wednesday.
Additional function.
That's it. I hope it's clear, right? Keep practicing. Guys, those who are online, any doubt?
Understood, sir.
Okay, we'll wind up then.
Thank you, sir.